You may not have heard about gallium nitride GaN, but it's quickly becoming an increasingly important technology in the smartphone space. This next-generation semiconducting material is likely to make an appearance in your next smartphone charger as well as that new 5G radio tower in town. Companies, including GV, formerly Google Ventures, have been pouring money into GaN research over several years, and the investments appear to be paying dividends. Here is everything you need to know about gallium nitride and why you should keep an eye out for it. What is gallium nitride and what does it offer? Gallium nitride is a chemical compound with semiconductor properties, researched and studied as far back as the 1990s. Electronic components manufactured using GaN include diodes, transistors, and amplifiers. This puts it in the same family as silicon, the most popular semiconductor material that you may have heard more about. GaN offers a number of benefits over silicon-based electronics thanks to its wider band gap. The band gap essentially measures how easy it is for energy to pass through the material. GaN's properties include higher temperature limits, high power handling capabilities, and 1,000x the electron mobility versus silicon. However, GaN isn't really suitable as a direct replacement for silicon transistors used in low-power application processors across today's gadgets. Instead, GaN's efficiencies are most beneficial in higher power situations, where its 3.4 eV versus 1.1 eV band gap really comes into play. GaN is a superior semiconductor to silicon, but it's more expensive. Where GaN appears particularly promising in the gadget space is in 5G antenna radio and power technologies, as well as ultra-fast charging accessories. The key thing to remember is that GaN offers better thermal and power efficiency in a smaller area than traditional silicon parts. Gallium nitride chargers. Smartphone owners are increasingly familiar with very fast charging technologies. 30W to 40W is very common now, while some companies are even pushing 60W charging. While not unwieldy, these higher power chargers have begun creeping up in size and also dissipating, wasting much more heat than their lower power predecessors. The move to GaN shrinks the size of chargers while also ensuring cooler, safer charging. Power transfers from the charger to devices more efficiently using gallium nitride materials. This is even more important in higher power devices. Laptops, for example, require even more power to charge than phones and are often lumped with large power bricks. GaN can free laptops and other high-power gadgets to run on smaller chargers. Gallium nitride chargers are smaller and more efficient. GaN-based electronics, such as power amplifiers and radio front-ends, could appear in a wide range of 5G devices. Ranging from microcell base stations that make use of GaN's smaller feature size, through to large transmitters where heat wastage is the primary concern. Gallium nitride may also turn out to be crucial in other power-hungry 5G technologies, including envelope tracking and beamforming antenna arrays. 5G mmWave facts and fictions you should definitely know. 5G networks are upon us, and this next generation of wireless communication is being powered by a new technology known as millimeter wave mmWave. US carriers are particularly keen on the technology, and it will likely be. The biggest drawback with gallium nitride is, once again, its cost and unfamiliarity in the market. While research is gradually making the technology more affordable, its benefits are most pronounced for very high-frequency mmWave technologies. GaN may have a harder time competing with silicon's economies of scale when it comes to sub-6 GHz 5G. In summary, gallium nitride is likely to be a key material used to improve the efficiency of emerging 5G technologies. Keep an eye out for GaN in your next power adapter too. It's already a growing player in the fast charging market. A GaN hub is a type of USB-C hub that uses gallium nitride (GaN) technology to provide faster charging and data transfer speeds. GaN is a semiconductor material that is more efficient than traditional silicon, which allows GaN hubs to be smaller and lighter than their silicon counterparts. GaN hubs offer a number of advantages over traditional USB-C hubs, including faster charging speeds. GaN hubs can charge devices up to twice as fast as traditional USB-C hubs. Faster data transfer speeds. GaN hubs can transfer data up to 4 times as fast as traditional USB-C hubs. Smaller and lighter design. GaN hubs are smaller and lighter than traditional USB-C hubs, making them more portable. GaN hubs are a good option for users who need to charge devices quickly, transfer data at high speeds, or need a portable hub. Here are some of the best GaN hubs on the market. Hyperdrive Thunderbolt 4 Power Hub. This hub offers 40 gigabits per second data transfer speeds, 32 gigabits per second PCI data transfers, and dual 4K 60 Hz or single 8K 30 Hz display connectivity. Invaji Gunhub 9-in-1 100W GaN USB-C charger power hub docking station. This hub offers 100 W of charging power, a gigabit Ethernet port, 4K at 60 Hz HDMI, audio jack, 5 gigabits per second data port, and SD and TF card slots. ADG 9-in-1 100W GaN charger USB-C docking station. This hub offers 100 W of charging power, 4 USB ports, 4K at 60 Hz HDMI, Ethernet, micro SD, audio and mic. These are just a few of the many GaN hubs available on the market. When choosing a GaN hub, it is important to consider your needs and budget.